All right, let's talk about cloud data engineering. Today, we're going to break down the essentials, pulling some great insights from the guide Cloud Data Engineering for Dummies. Our goal here is to cut through the jargon and really get to the heart of how companies manage that massive, constant flow of data, and why the rulebook has been completely rewritten in just the last few years.
So here's our game plan. First, we'll get to know the architects of data, what data engineers actually do. Then, we'll cover the huge shift from old-school methods to the modern cloud. We'll walk through what a modern data pipeline looks like, then zoom out to the people and processes that make it all work. And we'll wrap up with a playbook you can use to get started.
Okay, so first up, the architects of data. We hear the term data engineer thrown around all the time, right? But what is their fundamental role? What do these folks actually do all day? Well, let's frame it with this question. If you think of data as the absolute heartbeat of a company, the lifeblood pumping through every department, then what's data engineering's job? Well, it's to keep that flow healthy, strong, and consistent. That, in a nutshell, is the mission. A great way to think about them is as both architects and builders. They're the ones who look at all this raw, messy, totally chaotic data and design and build the systems to turn it into a valuable asset. They make it production ready, which is just a way of saying it's clean, reliable, and actually usable for everyone else, from data scientists to the marketing team. And trust me, the scale of this challenge is just immense. We're not talking about a few spreadsheets here. Today's data engineers have to pull in information from this incredible mix of sources. You've got giant data lakes, you've got real-time streams pouring in from IoT devices, data from dozens of different SaaS tools, web logs. It's a complex, tangled web that needs a really smart system to manage it all. But it wasn't always this complicated. This level of complexity is actually a pretty new thing. To really get it, we need to look at this massive technological shift that basically changed everything, moving us from the old world of data into the new cloud era. You can kind of see it in three acts. You had the old world, where everything was on-premise. It was slow, crazy expensive, and could only handle neat, structured data in these big, clunky batches. Then came the cloud revolution. Suddenly, storage costs just plummeted, while processing power went through the roof. This created the new world we're in now. It's fast, it can handle any kind of data you throw at it, and it can scale up or down in an instant. And that massive tech shift, it completely flipped the process on its head. We moved from the old way, known as ETL, that's extract, transform, load, to the new way, ELT, extract, load, transform. Now, I know it seems like just flipping two letters, but believe me, this represents a complete paradigm shift in how we work with data. The cloud is really what made all this possible. It gives you basically limitless capacity and this incredible elasticity. You can scale up for a huge job and then scale right back down. Plus, you only pay for what you use, which is super efficient. All this together allows for a totally new strategy. You can just capture everything first and figure out what questions to ask later. It's a real game changer. Okay, so with that backstory, let's get into the nitty-gritty. How does a modern data pipeline actually work? When you boil it all down, it comes down to three key stages: ingest, transform, and deliver. Here's the framework. Nice and simple. First, you have to ingest and collect all that raw data. Second, you transform and clean it up so it's reliable. And third, you deliver and share that polished data with the people who need it to do their jobs. So, step one, ingest. This is all about getting the data in the door. And a modern pipeline has to be super flexible. It's got to handle big, scheduled batch loads from your enterprise apps, but also handle continuous real-time streams from, say, your website. And it often uses powerful tech like Kafka, which is built to handle these massive, nonstop data flows. Okay, once the data is in, we hit what is maybe the most critical step of all. And it's all governed by that age-old, brutally honest rule: garbage in, garbage out. Because if your data is a mess at this stage, everything that follows, every analysis, every report, every decision is going to be flawed. And this is where that ELT model we talked about really shines. Instead of doing the cleanup in some slow, separate system, you load the raw data first directly into a powerful cloud data platform. Then, you use the massive processing engine of that platform to do all the heavy lifting, the cleaning, the combining, the transforming, right where the data lives. It's way faster and so much more flexible. And finally, we deliver. The old way was frankly a mess. You'd make copies of data and send them out using clunky things like FTP.
It was slow, it was insecure, and the data was often stale by the time anyone used it. The modern way is totally different. It's all about providing secure, live access to the data exactly where it is. No risky copies, just one single source of truth. Now, having the right tech is one thing, but a successful data practice is about so much more than just pipelines. It's about the people, the processes you follow, and the rules, the governance that holds it all together. And that leads us to a really important concept called data ops. If you've heard of DevOps in the software world, it's pretty much the same idea, but for data. It's about applying those same agile principles, collaboration, automation, continuous improvement, to the entire data lifecycle. It's a culture shift, really. But for data ops to actually work, you need a rock-solid foundation of governance. You have to be able to answer these 5 absolutely critical questions. Where did this data come from? Can we actually trust it? What data do we even have? Who has permission to see it? And who changed what and when? If you can't answer those, you can't have reliable analytics. And answering them takes a village. It's not just the data engineers hiding in a back room. You need a chief data officer for strategy, data analysts who know the business inside and out, and data architects with the technical vision. And so importantly, you need data stewards, people from the business side who actually own the data and are responsible for its quality. So, we've covered the what, the why, and the how. Let's pull this all together into a practical playbook. 6 steps you can take to start building a modern data engineering practice in your own organization. Here's the plan. First, start small but think big. Pick one project that will deliver real value fast. 2, simplify your architecture. Don't try to build everything yourself. 3, get your stakeholders on board early. 4, and this is a big one, build in governance from day one. Don't make it an afterthought. 5, use a cloud platform to be as efficient as possible. And 6, always be looking ahead to what's next. And through all of this, you have to remember the ultimate goal. This isn't about tech for the sake of tech. The whole point is to get trusted, reliable data into everyone's hands, making it a natural part of how they work every single day, so they can make better, smarter decisions. And maybe the single most powerful shift you can make is this: adopt a product mindset for your data. Stop thinking about data as just this exhaust that your business creates. Start treating it like one of your most valuable products, an asset you can develop, manage, and deploy to create real, tangible business value. So, I'll leave you with a final thought to chew on. As data becomes more and more central to literally every decision we make, how are these modern data engineering practices going to shape the future of your industry? And what new skills are going to be the most vital for success? Something to think about. Thanks so much for joining us.